Imagine sending a text, moving a robotic arm, or even speaking just by thinking. This isn't science fiction anymore. Brain-computer interfaces, or BCIs, are real, and they might just change what it means to be human.
BCIs originated in the 1960s and 70s, with early research showing that brain signals could control machines. Since then, they evolved from basic EEG experiments to advanced systems like Neuralink, which in 2024 successfully implanted a BCI in a human, opening the door to treatments for paralysis, vision loss, and beyond. Neuralink received approval to begin human trials in the US. In January 2024, Musk announced the first successful human implementation. Neuralink also recently announced BlindSight, a system aiming to restore vision to blind individuals by stimulating the visual cortex.
This is a basic block diagram of how a BCI system works. First, electrical activity within the brain is extracted and then digitized. Feature extraction and classification are performed using electronic algorithms, which then convert those signals into commands for an application, such as moving a robotic arm or controlling the cursor on a computer, which then provides feedback to the user through a screen or potentially another BCI.
Building BCIs requires teamwork across disciplines. Electrical engineers develop the electrodes and ensure safety, while biomedical engineers focus on implant materials and compatibility with brain tissue. Computer scientists and AI experts train algorithms to interpret brain signals into usable commands. Beyond engineering, neurosurgeons perform the delicate implant procedures, and neuroscientists decode how thoughts become signals.
So now about the ethical issues and concerns. First, there's animal testing. So the Neuralink has faced heavy criticism after euthanizing a large number of primates during their early testing trials, and records show that the monkeys experienced severe complications due to implanted electrodes. Next, we have the human risk. So invasive BCIs like the Neuralink can pose health risks, which include brain infections, hemorrhage, and long-term tissue damage. And even non-invasive versions expose users to constant electromagnetic fields. Thirdly, we have privacy and security. So BCIs collect neural data, which raises questions like, who owns your thoughts? And so, indeed, many people underestimate the amount of data that their devices is taking from them. So now imagine how much more data BCIs will be taking from you. Also, without regulation, these devices could be vulnerable to hacking, which is a threat known as brainjacking, although cybersecurity expert Robert Grimes says that it's highly unlikely, since the only way to hack a Neuralink is if the hackers knew the source code of the device. Then we have social inequality. So Neuralinks are very expensive. For reference, other BCIs can cost from around $5,000 to $10,000 without considering the cost of operation. So they're only accessible to the wealthy, which can widen social inequality. Lastly, we have autonomy and responsibility. So if a BCI can influence decisions or behavior, who's responsible if something goes wrong? Is it the user or is it the developer? Since there's no precedence in this legal system for these types of issues, this remains to be seen.
Neuralink could revolutionize medicine by restoring mobility to paralyzed patients and treating neurological disorders. It may also enhance cognition, enabling faster learning and direct brain-to-device communication. However, such advancements raise concerns about privacy, as brain data could be hacked or misused. If only the wealthy can afford these enhancements, it may widen social inequalities. Additionally, merging mind with AI challenges our understanding of human identity and free will. The technology could transform how we interact, potentially making telepathy a reality. Yet, over-reliance on brain implants might weaken natural human abilities and deepen social isolation. Ethical and regulatory frameworks will be crucial to prevent misuse, such as surveillance or mind control. While Neuralink offers exciting possibilities, society must be careful society must carefully navigate its risk to ensure it benefits humanity as a whole.
Brain-computer interfaces are no longer the stuff of science fiction. They're here. The question isn't, can we do this? The question is, how do we do this responsibly for everyone?